Hello everyone, welcome to my channel where we are learning DSA concept wise. So let's have a look at today's problem. So we have given a linked list and our task is to reverse it. So let's take an example and understand from that. Let's say we have this linked list. This is the root or we can say head of the linked list. So after reversing this, the new linked list will look like this. So the first approach that we can use is we can create a new reversed linked list. So let's see how we can create a new reversed linked list. So as we have given the root, so we will run a while loop until the root reaches to null. So let's see. Now create a new node. Let's say temp. So now we have this node in temp. And let's take one another variable node previous. And initially it is null because initially previous is null. Before this there is nothing, so previous is null. And let's assign temp.next to previous, and now make previous to temp and move through to next root node. So here in this way, in last after this loop we will have previous as the head of new linked list. New linked list. Now if we see the time complexity of this approach, then we can say that it is big of n because we are running a loop from root to end of linked list. And the space complexity is also big of n because here we are creating a new linked list. Every time we are creating a new node, and in last we will have n nodes, and the head of the new linked list will be this previous. So now let's see how we can optimize this. We will try to reverse the linked list in constant space, and we will reverse the linked list in place. What is that mean? Instead of creating this new linked list, we will try to reverse the pointers of the actual linked list, and we will destroy these pointers and create new pointers. So let's see how we can do that. So we have given this linked list and we will try to reverse it in place. Means we will reverse the pointers of the nodes and we will destroy the previous pointers. Now let's see how we can do that. Same as previous, we will run a while loop from the head to the end of the linked list while root not equal to null. And now we will take the current node and we will move root to root dot next. So now current is this and root is this. Now let's take another node next and set it null initially. So now as we can see that we have this node current, we will assign the next of this current node to next like this, and we will make next to current, and we will close our loop. So here we have this current one node, and we set its next to null, and now we set this next to this current. So now in next turn we will have this 2, and we will move our root to next do dot next, and we will set current dot next to next. So current is this 2 and next is this 2. So we will set 2 like this, and we will move next from here to here, and in next turn root is this. So we will have current this 3, and we will move root from here to here, and we will set the next of this current to the next like this, and we will move this next from 2 to this 3. Similarly, when it will reach to 4, 4 will be our current, and we will set the next of 4 of the address of this 3. So in last we will have a new linked list like this way, and next will be the head of this new linked list. So now if we look at the time complexity is big of n because we are running a loop from root to end of the linked list. But if we see the space complexity is big of 1 because we are not creating a new linked list, we are reversing the linked list in place. We are just modifying the pointers. Now let's try to run this logic. So here we have given the head of the linked list, and as we have saw in our approach that we have executed a loop from the starting node to the end of the linked list. So let's run a loop while loop from starting node to end while head not equal to null. And we took the current node of the linked list. Then we moved head to the next node. Here we took another node, let's say next, and we set it to null initially. Now we set the next of the current node to the next, and we moved next to current node. And in last, we had the next as the head of the new linked list. So let's try to return this next. Let's run it. So here we can see that linked list has been reversed. Now let's submit it. In this way, we can reverse a linked list.